Hi, today we're going to be solving higher order polynomials, but we're first going to start with our quadratics, and then we're going to, today though, focus on cubics and quartic equations. So for numbers 1, 2, and 3, we're going to first do it the graphic way. And if you recall, that means that we're going to type this into our calculator, get the graphs, and see where the two sides meet or intersect. Okay, and then don't forget that you really want to probably go over on the 84s anyways, go over to the end and bold the 0 line, because otherwise it's sometimes difficult to see. All right, now we'll press graph. Okay, so I can see where the answers are just by seeing where the x squared minus 4x minus 5 graph intersects the 0 line. All right, so just making a rough sketch. Okay, so there's the y equals x squared minus 4x minus 5 graph. Here's the y equals 0 graph. They're definitely crossing at -1, 0 and 5, 0. And recall that if you really are not sure, because the pixels are a little off on the 84, you can always go to the table and just make sure that in fact 5 is hitting 0, which it is, and same thing with -1. All right, so recall that the answers are where they intersect, and it's the x answers we're solving for. So the x coordinate of those points are your answers. All right, going on to the next question. This is a cubic equation. It's got a highest power of x cubed. We can always solve these this way as well. All right, we already have our 0 in. So if we, whoops, sorry. Okay, now I typed it in properly. We look at the graph, and you see this funky graph. All right, so this graph is shooting like this. All right, this is the graph. Y equals x cubed minus 3x squared minus x plus 3. This is my y equals 0 graph. And I can see, again, that they're hitting at these 3 spots. And this is hitting, I could check the table, but this is hitting at -1, 0. That's hitting at 1, 0. And this one's hitting at 3, 0. So your answers are the x coordinates of those points of intersection. So x is -1, 1, or 3. Okay, moving on to the fourth one, or example 3, excuse me, the 4 power. This is the quartic equations, because the highest power is a 4. And I'm also going to type this one in. And the 0 line is in. And these don't always look like this, but this is kind of interesting. It kind of looks like a W. They sometimes can actually look like a U also. All right, so there's my quartic. Y equals x to the 4th minus 5x squared plus 4. Here is my y equals 0 line. Okay, and this is the point -2, 0. That's the point -1, 0. That's the point 1, 0. And that's the point 2, 0. And so we have the answers are the x values, -2, -1, 1, and 2. Now, if you go back to question 4, what do you notice between the highest power of the polynomial and the number of answers the equation has? Well, very interesting. Our highest power of the first problem was a 2, and we have 2 answers. Our highest power of the second problem was a 3, and we had 3 answers. And our highest power on the third example was a 4, and we had 4 answers. So the relationship is the highest power tells you how many answers to expect. Or how many answers it has. Let's say it that way. Now, there are times where it has less than that, and if you recall, sometimes you can get equations that have equal roots, called double roots, or we can have triple roots. So it's the same answer like 2 times or 3 times. That's possible, and if it does show up twice, it still has 2 answers. They happen to be the same. So a 4 power can have up to 4 answers. It's possible it has only 2 answers if they share 2 of the same equal answers. You can have 2 answers. Okay, so that's just a visual approach to the graphing, and now we're going to do the algebra. So I'm going to put up the vocab, and you can pause it if you want to write them. Quadratic equation is an equation where the highest exponent of the variable is a square, or power 2. And a cubic is an equation where the highest exponent of the variable is a cube, 3. And a quartic is an equation where the highest exponent of the variable is a 4. Okay, so in order to learn how to solve the cubic and the quartics, these are what we're going to focus on actually today. In order to solve these, first you have to know how to factor a cubic. Well, factoring a cubic is no different than when I showed you the AC method to factoring trinomials that begin with a front number other than 1. So in order to graph these, we are going to do it by the factor by grouping method. And these, again, at your level, these, when you see a cubic, you know that you're going to be able to do these. In real life, not all cubics can be factored this way, but the ones I'm going to give you this year will be. So again, this just follows the same thing you would do with the AC method, but it's already in 4 terms. So you're going to group the left group and the right group. You're going to do the GCF of each group. And the GCF of the red group is x squared. And remember, you want to take out the highest amount that you possibly can. If you take out an x squared, you have an x minus 2 remaining. From the blue group, don't forget, whatever sign that is gets pulled out. We're going to pull out a positive and then a 9s in both groups, or both terms. And if you do this properly, then each of your 2 sides, the blue side and the red side, will have a like factor in it. We pull that factor out. And leftover pieces, x squared plus 9, come together. And then at this point, remember, factoring means to just factor. I'll have a lot of students who will start throwing in equal zeros. This did not say solve, so there's nothing to solve for. In addition, if you could factor either of the 2 terms, x minus 2 or x squared plus 9, the 2 factors, excuse me, then you would continue to factor again if you could. But x squared plus 9 is not dots, all right? Not dots. In order for it to be dots, difference of 2 squares, it has to have a difference, which means a minus sign. So that is not x minus 3x plus 3, which a lot of students want to write. All right, moving on to the next problem, factoring that one. Again, if it's a 4-termed cubic expression, you know that you're going to be able to do factor by grouping, at least at this level. So we're going to pull out our GCF from both groups. And don't forget that sign comes out. All right, in the red group, there's a x squared again in common. And there also could be numbers in common. There just haven't been in the problems I gave you, but there may be. 3x minus 2 is left over. In the blue group, I can take out a negative and also a 4. So if I take out a negative 4 from a negative 12, I get positive 3x. And I take out from an 8, divide out a negative 4, I get a negative 2. Okay, looking at my two factors, I have the same piece, x minus 3 in common with both sides. And that means that I did do it right. I'm going to pull out the 3x minus 2. And then the x squared minus 4 comes together. But this actually is not done because x squared minus 4 is in fact dots. So on this one, you don't want to stop there. If it can go again, you want to. X squared minus 4 is x plus 2, x minus 2. And then don't forget to keep that first factor in front. And then that would be your answer. All right, so those are factoring cubic expressions. Now we're going to go on to the next page, which is solving them. And this should make sense. We're going to solve these like we do a quadratic equation. We're going to factor it. And then after we factor it fully, we're going to set all the factors equal to 0. Because we're going to use the zero product rule. So again, this is a solving problem. That means we are in fact going to go to x equals. So there's my left group. There's my right group. My GCF is an x squared. And then you have an x plus 2 remaining. All right, the blue group, you can take out a negative and then also a 25. So then you have an x minus 2 left. Oh, sorry, x plus 2. We're dividing out a negative 25. Okay, equals 0. They do, in fact, have the matching factors on both sides. So I'm going to pull that out. The other two come together. And with solving, you don't have to go on again with factoring. You could set them both equal to 0 right now, but I notice that this right here is dots, so I'm going to factor again. Okay, keeping x plus 2, and then factoring x squared minus 25 into x plus 5, x minus 5. All right, and setting all the factors equal to 0. All right, and there are 3 answers, which is what we expected because we had a power 3 as our highest power, so we expected 3 answers. All right, we'll try this 2 more times, and then we'll deal with quartics. Okay, GCF. The GCF from the blue group is x squared. Then you have 4x minus 3. All right, from the red group, I have a negative to pull out. And then I have a 5 as a GCF. Again, be careful that the positive 15 divided by the negative 5 changes signs. All right, we do in fact have our equal or like factors. We pull that out. And then put the other 2 terms together. X squared minus 5 is not dots. So therefore, we are done factoring. We're going to set both equal to 0. All right, the left side, add 3, and then divide by 4. And the right side, we add 5. And then to get rid of a square, we take the square root. But don't forget positive and negative square root. Now, if you did not put the positive and negative on the square root, you would only gotten an answer of 5. And therefore, you only have 2 answers. And the highest power is 3, so you should have expected 3 answers. That will help you to understand that you did something wrong, and hopefully you'll remember that there's actually 2 signs on the square root. And then there are our answers. You can leave it like that, or you can separate them. But on a multiple choice, you will see a positive negative 5 written like I did originally. All right, one last one of these, and then we'll do quartics. All right, so GCF and then the GCF. All right, in the blue group, there's an x squared in common. All right, in the red group, I take out a positive, and then I take out a 4. And there are my like factors again, pulling those out. All right, again, x squared plus 4 is not dots. It does not have a minus sign, so not dots. So that means I can just start setting both equal to 0. All right, subtracting 4 over, I get x squared equals negative 4. Taking the square root, don't forget positive and negative. You get, well, we have a negative underneath the radical, so if you recall, that means I. And the square root of 4 is 2, so this is positive and negative 2i. And there are our 3 answers, negative 3, 2i, and negative 2i. Again, you most likely will see it written like this on a multiple choice, or you can leave it like that, or you can separate the answers out. All right, and lastly, the quartics, the power 4. Now, these are particular ones that we're doing, because a power 4 can actually have up to 5 terms, because it could have a 4 power term, a 3 power, 2 power, 1 power, no power of x term. So we're only doing these special cases. And these special cases are where it has 3 terms. The x to the 4 is the first term, and then x squared, which is half the power, is the second term, and then the no power is third. So particularly only the quartics that go in this order, 4 power, 2 power, no power. In order to factor these, you're going to factor these the same way we do regular quadratic equations. So for instance, this begins with a 1, so what multiplies to 64 and adds up to negative 20. So factoring these just like a normal trinomial. And again, to help me out here, I'm going to use my table on my calculator. All right, I'm going to do 64 divided by what number? And then see which one of these adds up to negative 20. Oh, negative 4 and negative 16. All right, now the only difference is this is not an x squared term, that's an x to the 4th term. So we're going to split it up into x squared and x squared. And then the 64 numbers, we're going to use this pair that adds up to negative 20, so negative 4 and negative 16. And then don't forget that since our highest power is a 4, we should expect 4 answers. Now remember, all the answers don't have to be nice answers. We just did the cubics where some come out to be i's and some come out to be radicals, and that's okay. Those are still answers that count in our numbers. Now x squared minus 4 times x squared minus 16, these are actually in fact factorable again. Each one of these is dots. X squared minus 4 is x plus 2, x minus 2. And x squared minus 16 is x minus 4, x plus 4. All right, setting the factors all equal to 0. And there are our answers. And we did get our 4 answers, negative 2 and 2, negative 4 and 4. Okay, so the next one, we have to again, this is another, it looks like a trinomial type, and we're going to factor it just like that, except the x to the fourth. It's going to be x squared and x squared. All right, so if I go back to my table to help me out, I'm going to insert a negative sign and then see which one of these pairs adds up to 12. Okay, so it's got to be positive 12, so 16 and negative 4. All right, x squared minus 16 plus 16 is not dots, but x squared minus 4 is. Now, you can factor it again, or we can do the whole square root and get our two answers that way. I like to factor fully, but you don't have to. Okay, now setting all the terms equal to 0. All right, subtract the 16 over for the first factor group. Taking the square root, don't forget the positive and the negative. And we have a negative underneath the radical sign. That's going to imply an I, and the square root of 16 is 4. So it's positive and negative 4i. So there's our two answers, and then we have two more. So our answers are equal to positive and negative 4i, 2, and negative 2. All right, we'll try one more again. Okay, our x to the fourth with our three terms with a power 2. So that means regular trinomial graph or factoring. Okay, so it multiplies to negative 54 and adds up to 3. Again, I can do that because it begins with a 1. If it did not begin with a 1, we could factor it like we did the AC method. Okay, so adding up to get a 3, positive 3, there's our 9 and negative 6. All right, x squared plus 9 is not dots. X squared minus 6 is not dots. So we cannot factor any further. Setting both factors equal to 0 and solving. X equals positive and negative 3i. Then the other side, bringing over the 6, then square rooting again. You get x equals positive and negative square root of 6. So we do, in fact, have two answers, positive 3i, negative 3i, positive radical 6, negative radical 6. And then those are our answers. Again, you can leave them like that. That is fine. And again, we did get our 4 answers. Power 2s have 2 answers at most, or less if they have equal roots. Power 3s have 3 answers, again, or less if they have double roots or triple roots. And same thing with power 4s. They're going to have 4 answers, or again, or less if you have double or triple roots in there as well.